So dear students, greetings of the day. We are present here to discuss one important concept in functions, and that is the recursive functions. So what is a recursive function? It has a very simple definition which says a function calling itself is called a recursive function, or simply calling a function from the definition of the same function is called a recursive function. Basically, this allows the function to be repeated several times, since it calls itself during its execution. Functions that incorporate recursion are called recursive functions. Calling a function from the definition of the same function is called recursive function. We will see one example of a recursive function where a function is being called from the function itself. Let us consider a small C code which is calling its main function explicitly from within the main function. Here we are writing a main function, and the first statement says printf start. The next statement, I want to call a main function explicitly, and of course first time the main method is executed by the operating system, and the second time we are calling the main method. Next, here we are writing one more statement, printf end. So start message and end message, two statements we have written. In between the start and end, we are calling the main function. Now we see how it executes. So generally, to execute functions in the application, right inside the RAM, a memory will be allocated. The memory is called the stack memory. This is not only in a C language, but in any programming language, stack memory is common. Any function or any block execute inside the stack memory only. To execute a method or block, some amount of memory will be allocated inside the stack. That is called the frame. A particular amount of memory will be allocated for every method execution. See, first time, whenever we start executing this program, operating system invokes the main method. So to main method, some memory will be allocated. So here a main frame will be created. The amount of memory will be allocated to execute all the three statements defined inside the main method. So in this main method, we are writing printf start, and then the second function, that is the second line of the main function is executed, where we are calling the main function explicitly. And once you may be now you will be asking a question, for this method where is the frame? Yes, for this main function another main method will be executed, or a main frame will be created. The first control move to here, and inside the main function and inside the main frame, all the three statements we should execute. All the three statements means the first statement is a start, and what is the second statement? We are calling again the main function. Here it is important to see that main function is being called again and again from the main itself. Every time the control is moving in a forward direction only. Once all the three statements execution is completed, then the frame will be deleted and the memory will be assigned to or released to some other execution of a method. But here, every time the control is moving in a forward direction only. For the control, there is no chance to come back and complete the execution of a previous frame. So it will continue to do so, and a time will come when the allocated memory will be full. Here it will be giving you an error, that is the runtime error it will give. Runtime error or out of memory. Your program will terminate abnormally because sufficient memory is not there. Since sufficient memory is not there in the stack to continue execution of your program, so that is a problem. So while working with recursive functions, one should be a bit careful while writing the logic, because in which order the control is going in the forward direction, in the same order the control should come back, and where it starts the execution, there only it should complete the execution. In that format only we should write the programs. Let us consider another example where we are writing a C code to find the factorial of a number n using recursive techniques. Here we are declaring a function integer fact of type integer, and we have declared it that only one argument will be there of integer type. Then we are writing a main function, and inside the main function we are declaring integer n as a variable and res for the result. Now we are asking here in the main function printf enter a number. So we accept a number into n variable by using the scanf function. Next statement we are writing that result res equals to fact n, where we are calling explicitly this fact function with an argument of the input n, and we are printing the factorial of n with this result res. In the definition of the function where we are writing integer res, if n equals to 0, result should be 1. Why we are doing so? Because the factorial of 0 is 1, and else it should return res equals to n into fact n minus 1. This is basically the recursive function we are calling. Let us see the execution and the main frames that we have, the method frames that are going to be created, so we can understand its execution technique. So there will be a main function, and inside the main function we are passing the argument of n equals to 4 with result res. Now res is being called by the fact function is being called, and the result will be stored in this res variable. Fact 4. Now this value of n is being taken as an argument in the fact function, and we are calling it explicitly from the main function. Now let's see how this fact function is being executed. Now this fact function will call the definition of the fact function, and inside the fact function we are writing the code if n equals to 0 or 4 equals to 0. So since the condition is false, it will not execute the first statement, but it will execute the else statement. And so we have marked it with a cross and this one as a right tick. Now res will be equal to now 4 into fact of 3. Now when fact of 3, again a fact function is being called from this function. So next statement will be fact n equals to 3. Next method frame will be of fact equals to 3 for n equals to 3. If 3 equals to 0, now again the condition is false. So we mark it with a cross that the first statement will not be executed and the else statement will be executed. Then res equals to 3 into fact of 2, n minus 1, n into n minus 1. So now again fact 2 will create another method frame with fact function. If 2 equals to 0, now again the function is false, the condition is false, so the first statement will not be executed and the else statement will be executed. Then result equals to 2 into fact 1. Again this fact function is calling a fact function again. For that it will create a method frame again with fact n equals to 1, and in this condition it will check if 1 equals to 0. again it is a false function, false condition. Else the else statement will be executed. Here it says result is equal to 1 into fact of 0. Now this fact of 0 will again create a method frame in the forward direction, which will be like this. If 0 equals to 0, now the condition is true, and once the condition is true, it says in the first statement that res equals to 1, and we have seen that res will be returned when the condition is true. So this res value will be returned and res will be equal to 1. This 1 will be moved to this where the method frame of fact n equals to 1 is there, and this value of res will be 1 into fact of 0. The fact of 0 result is 1, so 1 into 1 is again 1. So this will give me a result of 1. This will be again moved to the fact where n equals to 2 is given. This will calculate it as res equals to 2 into fact of 1. Fact of 1 we have previously calculated as res equals to 1. Now this 2 will be multiplied with 1. It will give me res equals to 2. This res equals to 2 is again now going to be fetched by the fact function or the method frame where n is equal to 3. Here again res will be equal to 3 into fact of 2. Now we have calculated fact of 2 in the previous method frame, that is 2. So it will calculate as 3 into 2 and it will be equal to 6. This res will be again returned to the fact method frame where n is equal to 4 for the function. Now 4 into fact of 3 is 4 into 6 that we have previously calculated, and it will come out to be 24. This final res equals to 24 will be transferred to the main function and the res result will be calculated as 24. So we see finally that the factorial of 4 has been calculated with this method of recursion. So recursion can be used as a tool to for fast calculations in your day-to-day programming life. So this brings us to the end of this lecture. I would request you all to go through the video, and if you have any queries, you can put or push me through emails, or you can post it as a comment in the comment section below. Thank you.